In this video, I'm going to be covering Unit 1, Section 2, Classification of Matter. But first, let's define what matter is. Matter is anything that has weight or mass and takes up space or volume. Really, in chemistry, it's everything. Air is matter, carpet is matter, food is matter. Really, everything we deal with is made up of matter. So, what are the different types of matter? Well, the purest kind of substance, or the purest kind of matter, we refer to as an element. And this is a substance that is made up entirely of identical parts. So, take, for instance, these bars of gold. These bars of gold, every single part of them is the exact same thing. Same with this aluminum baking dish and this neon sign, the neon in the sign. Those are all elements. They're the purest kind of matter. What is the smallest piece of an element? We call that an atom. And really, our simple model of this, which we'll revise in a later unit, is a simple hard sphere. So if we think back to that bar of gold, this might be the smallest piece of that gold. It's still an element, it's just that single piece. Know that not all atoms are the same. On this slide, I have 4 different elements: carbon, boron, beryllium, and lithium. And by themselves, these represent single atoms of those 4 elements. And where do we find those elements? Well, we have a periodic table. This periodic table lists all of our elements. We go start here at hydrogen in the top middle, and we progress through helium in the top right, all the way through this table, reading it from top to bottom and left to right. But really, these are just the different elements, that different purest form of matter. Now we have to introduce something called a compound. An atom is the smallest piece of any element, but a compound is what we get when we bond atoms together chemically. So if I take those hard spheres and I bond them together, they're no longer just an element, as long as there's 2 different kinds. Then we form a compound. And the weird thing is, compounds can have different properties than the elements that make them up. Take, for instance, sodium, this silvery metal, shown here at the bottom, an atom of the element sodium. In the center, the element chlorine, a yellowish gas, and down here we have a single atom of chlorine. When we put together that metal and that gas, we end up with good old table salt or sodium chloride. Notice though, this compound is made up of 2 different types of atoms bonded together. Now, if we wanted to kind of do a process to figure out if we have elements or compounds here, if I look at sodium up here at the top, and I try to find sodium somewhere on this periodic table, I'll find that sodium exists on the periodic table. Therefore, sodium is an element. We can do the same thing with chlorine. Notice that chlorine also exists as an element. However, if I search the periodic table for sodium chloride, that salt, I'm not going to find sodium chloride anywhere on the periodic table. And that's because sodium chloride is a compound. It's multiple elements put together. Our table only shows us the pure elements. And we'll use this later when we start to talk about all the different kinds of matter. So we have element sodium, element chlorine, and a compound for sodium chloride. Now let's talk about what happens when we mix things together. Elements and compounds, we say, are pure substances. They are one ingredient, and they have the same properties throughout every part of them. So those gold bars are the same throughout. Table salt is the same throughout. Mixtures, though, are combinations of elements or compounds where not every part is the same thing, or not every part has the same properties. For example, salt or sodium chloride, every piece of salt is the exact same as another piece of salt. But if I look at this fruit salad on the right here, not every part is the same. I have kiwis and strawberries and mangoes and pineapples, I can see the different parts. Not every part acts the same way. And these mixtures, we say, are physically bonded. We can separate out these pieces physically. We don't have to perform any chemistry. I can literally pick this salad apart and not change what those pieces are. And we have two different types of mixtures. First, on our left, we have homogeneous mixtures. These are mixtures where the different parts are not visible. There are multiple ingredients, but we can't see the difference. Basically, the differences are too small for our eyes to really see. Heterogeneous mixtures are any mixtures where I can literally see the different parts, such as my fruit salad on the right. Take, for instance, these two soups, corn chowder on the top and tomato soup on the bottom. In this corn chowder, I can see all those different pieces. I could pick them apart. Therefore, that's a heterogeneous mixture because I can see the different parts of the mixture. The tomato soup, on the other hand, is a homogeneous mixture because I cannot see the different parts. They're not visible. If we look at this on an atom scale, if I take kind of piles of atoms and put them together, on the right side, it's pretty easy to see this is a heterogeneous mixture because I can see pockets of this purple atom in the whole big mix of all the greens. On the left, this would be as if we were looking through a microscope. These atoms, these purple atoms, are pretty well mixed throughout. So as we're looking at it with our eyes, when I'm magnifying it to this slide, I can see the difference. But in reality, because this is very well mixed, I would not be able to see the difference if I looked at this sample on the left, and therefore it would be homogeneous because it's really well mixed. Now, our tool in class to tell the difference between the different kinds of matter is this flow chart. Notice that we're always going to start at the top, and we're going to ask ourselves a question to follow the trend of the flow chart. My first question here is my sample made up of one ingredient or many? And it says check info on the container. This would be if we had containers with ingredient lists. If I have one ingredient, I'm going to follow the right path, and that tells me I have a pure substance. But if I have many ingredients, I'll follow this left path, and that tells me I have some kind of mixture, either homogeneous or heterogeneous. Let's say I have a mixture. My second decision is, do all the parts of the mixture look the same? If they do all look the same, I have a homogeneous mixture because I can't see the differences. But if I can see the different parts of the mixture, I have a heterogeneous mixture because I can see those different parts that are visible. On the other hand, if I have a pure substance, my decision is really, can I find the substance on the periodic table? If I can, it's an element because it's one single element, it's one single thing. And if it's not on the periodic table, I have a compound because I have elements that are bonded together to form a new substance. Let's try out a little practice with this. First, I have this maple syrup here on the left. I see that it has three ingredients: water, sap, and flavor compounds. I'll start at the top of my flow chart. I can see I have many ingredients in this. I know three doesn't sound like a lot, but it's more than one. So I'll follow this left path here, saying that I have a mixture. And now, do all parts of the maple syrup look the same? If I look back at my picture over here, I would say yes, all of this maple syrup looks the same. Therefore, I have a homogeneous mixture or a solution. So my syrup is a homogeneous mixture. On to our next one. I see I have this tin can here, and it only has one ingredient, tin. So I'll start at the top of my chart. I'll follow the right path because I only have one ingredient. And now I have to look on the periodic table to see if I have an element or a compound. If I bring up my periodic table and I scan it for a little bit, I can find tin is right down here at number 50. Therefore, tin is indeed an element because I can find it on the periodic table. If I look at the next substance, water, water only has one ingredient, water. So we're also going to follow the right path here. However, If I bring up my periodic table again, I'm not going to find water anywhere on this periodic table. Therefore, water is a compound. It's multiple elements put together. And for my final example, a s'more, I can see that it has 3 ingredients, and you might see already that I can see the different parts. But let's use the flowchart one more time. Do I have 1 ingredient or many? I have many, so I'll follow the left path. Do all of the parts look the same? No, I can see the marshmallow, the chocolate, and the graham cracker, and therefore I have a heterogeneous mixture. I hope this helps you understand the different kinds of matter and how we classify them. Use the flowchart as well as the periodic table to help you on the quiz and the practice.